All right, so this last lesson in our unit is really just review on solving logarithm and exponential equations, and cleverly titled Help for the Logarithmically Challenged. But really, it's just extra practice and trying to discern which method do I do, exactly what do I do in each situation. And so we kind of talked about these as we went through them initially, but now that you're going to kind of see them all at once, it won't hurt to go over the rules one more time. So if you have logarithm equations, an equation has an equal sign in it. Logarithm means it's got the word log written somewhere in the problem. Then the key is to be able to get the word to log to go away. And there are three things you can do. The first type, and even if you have multiple logs on each side of the equation, is to combine the logs and then you can just cross them out. So cross out is one method, but everything in the problem has to have a logarithm attached in order to use crossout. Second is most of the time seen like the second version here, where you have a number, no logarithm attached. This is the type that we are going to rearrange back to exponent form. Now, this top line looks kind of like a cross-out problem, but just remember that this logarithm has no variable in it, so we could solve it. 5 to what power gives me 25? 2. So these two equations actually are the same. This one is just written with the logarithm in it. So if we have a number, we can put it back into exponential form and then solve. And then lastly, we could just rearrange the problem if we have a single logarithm. So 2 to the third power equals 6x, and then we could solve from there. So just to rearrange, kind of like this method. So here we go. In this first one, every single term has a logarithm attached, so this is going to be like that cross-out problem. But before we can cross out, we have to combine logarithms. So remember that that comes over as an exponent. So I have log base a of x equals log base a of 3 squared, which is 9, plus log base a of 5. And so addition is going to become multiplication, and it gives me log base a of 9 times 5, or 45. And then I can cross out the logs, and x is 45. So the cross-out problems where everything has a logarithm, those are not too bad. Just be sure you combine your logarithms together so that you have a single log on each side before you try to cross it out. All right, in this next one we have a number, so we're going to rearrange back to exponent form, but again, before we can do that, we've got to combine these logarithms together. They do have the same base, so addition is going to become multiplication. So we have x plus 2 times 9. That's log base 3. So now we're going to rearrange. 3 to the third power equals 9 times x plus 2. 3 to the third is 27. Distribute and we get 9x plus 18. And then we're going to subtract. So 27 minus 18 would be 9. Equals 9x, then divide by 9, and x is 1. So rearrange and solve. Now, if some of you saw this logarithm right here, and you saw, oh, that one, we could simplify, which I don't know if you would notice or not, but if you did, sorry about that. Okay, so if you did notice that this one doesn't have any letters in it and that you could solve it, then you could do what we were talking up there in the second example. Before you rearrange it, we could solve that little piece. So log base 3 of 9 would be 3 to what power gives me 9 is 2. And then we could subtract the 2. And then we could rearrange 3 to the first equals x plus 2. So just subtract 2 and x is 1. You get the same thing no matter which way you go at it. Whether you combine the logs using multiplication or whether you saw that you could solve this and get a constant and move it to the other side. This one is easier, but you could still combine the logs and get the same answer. All right, this last one in this section, we're going to combine our logs. And again, addition becomes multiplication. So x times x plus 6. And then we rearrange. So 3 to the third power equals x times x. I think I said plus 6, but that's minus 6. So 27 equals x squared minus 6x. This one is quadratic. And when it's quadratic, we have to move it all to one side. And then we can factor. So it has to be x times x. 27 is 9 times 3. We want a negative 6, so negative 9 plus 3. Set those equal to 0, and we get x is 9, and x is negative 3. But again, don't forget to check, make sure those work. Negative 3 we can't use, so only x is 9. All right, so now for a quick review of exponential equations. Remember, the easiest way to solve an exponential equation is to try writing both sides as powers of the same base, get the same base. So this is the easiest way, but it doesn't always work. And that's only if your variable is in the exponent. If your variable is in the base, then you're going to use reciprocal exponents. So variable in the base, use reciprocal exponents. If the variable is in the exponent, the easiest thing is to get equal bases. And if that doesn't happen, if you can't do that, then you're going to have to take the log of both sides. So let's take a look. So here's one with a variable in the base. It's the only one with a variable in the base. So let's just call these 1, 2, and 3. So this would be method number 1. When the variable is in the base, then you just want to use reciprocal exponents. In this case, that would be 4/3. And so we just get x equals 80 to the 4/3 power. And I don't think we have a nice cube root of 80. And 80 to the 4th is not going to have a cube root either. So that's probably just one you're going to have to type into the calculator. It's going to be easiest to type in the calculator as an exponent instead of the cube root to the 4th power. So just 80 to the 4/3 power gives me 344.709, so 710. All right, so if variables in the base, isolate this variable and then use reciprocal exponents. All right, then for all of the rest of these, we have variables in the exponents. And so if we can do equal bases, which on this one I believe we could use base 4 or base 2. I'm going to use base 4. Then we want to do that because that makes it easier. 64 is 4 to the 3rd power. And so I can power to power multiply, minus 2 equals 4 to the 3x. And then I can cross those out, and x minus 2 equals 3x. So I'm going to subtract x, negative 2 equals 2x. Divide by 2, x is negative 1. Now, we could have done base 2, so let me go ahead and show you that. If you were like, oh, I could use base, you can. 4 would be 2 squared raised to the x minus 2 power. 64 is 2 to the 6th power raised to the x power. Power to a power you would multiply. So this would be 2x minus 4 power. And then 2 to the 6x power. And then we would get rid of our bases. 2x minus 4 equals 6x. Subtract 2x. We'd have negative 4 equals 4x. Divide by 4. And x is -1. So it doesn't matter which base you use as long as you get equal bases if possible. Now, if you had looked at that problem and didn't realize you could do equal bases and you did take the log of both sides, it will still work out. It's just that you'll have to have a calculator in order to do that. All right, so let's take a look at number 6 down here. We cannot do equal bases, so therefore we have to take the log of both sides. So log of 4 to the x power equals log of 50. Bring the x to the front. And we're going to divide by log 4. So this one, we're going to need our calculator to type in log of 50 divided by log of 4. So here we are, log 50 divided by log 4 gives me 2.82, round up to 2, so 2.822. All right, and number 7. In any of these problems, we want to still try to isolate x as much as we can. So the first thing I'm going to do here is multiply by 3 and get rid of my fraction. So I have 4 to the 2 minus x power equals 21. I cannot do equal bases here, so I'm going to take the log of both sides. So log of 4 to the 2 minus x power equals log of 21. I need to bring my exponent to the front. Remember, it's a binomial exponent. So we're going to distribute into that. So we have 2 log 4 minus x log 4 equals log 21. We need to get the x by itself, so I'm going to subtract this 2 log 4 to the other side. So negative x log 4 equals log 21 minus 2 log 4. And then I could divide through by negative log 4. I've got to divide through by the negative and the log 4. So that's gone, and x will equal this. So I need to type this into the calculator. All right, so we type all of that into the calculator, and remember to be really careful with all your parentheses. Let me show you on here real quick. You had to open a parentheses, open, close, close for the whole thing, open, close for the whole thing. So just be sure you get all those in there. So we get negative 0.196. All right. So hopefully this will help you out if you've been having trouble. These are kind of all of your rules. If your variable's in the base, reciprocal exponents. If your variable is in the exponent and you can do equal bases, do that. If not, then you're going to have to take the log of both sides like these. So this was number 1. This was number 2. And these were both examples of number 3.